Just a brief history. So my name is Vijay Tiwari. I'm the group program manager for the team that's responsible for bringing the Azure Stack into your data center. So if you look at Azure Stack, there are sort of two parts to Azure Stack, right? One is bringing all the magic of Azure services into the customer's data center. Services like SQL DB and the CRP, the NRP, all the wonderful services that are available in Azure. And then there is a second part, which is how do you as customers operate Azure Stack in the data center? What hardware do you run it on? That is my area of responsibility. So that's my goal, is to make sure that we build it in such a way that you as customers can operate Azure in your data center. Because in Microsoft, we've got like hundreds of engineers who are responsible for operating Azure in our data centers. And my goal is to actually bring that capability in some way, form, or shape that's digestible in a scale by all of you in your data centers. And so that's what me and my team does. So I represent the work of many, many teams across Microsoft, so thanks to all of them. And it's an honor to represent all their work here. And a number of them are actually here, even sitting here up front in here, right here. So do stop by and chat with them. Like I said, do come by the booth. It's a great opportunity to meet us and have a deeper conversation. So I'll start by a slide that was used by Mark Russinovich and Jeffrey Snover in their session, where they talked about what does it really mean to put the power of Azure in your data center, right? If you look at the right-hand side of this picture, it talks about Microsoft Azure, right? We've got 34 regions across the globe. And if you attended Scott Guthrie's keynote, you saw the amount of investment that we are making across those 34 regions. They have massive data centers, drawing huge amounts of power. They have multiple sources for networks. They have very, very large number of servers. A cluster in the context of Azure is close to about 1,000 servers. That's only one cluster. And it's not failover. It's not the traditional Microsoft failover cluster. They use a different context, but it's still called a cluster. And that's about 1,000 servers. And we have many such clusters in a region, and we have 34 regions in the world. That is what constitutes Azure. So it's hundreds of thousands of servers spread across many clusters, spread across many regions. And in those clusters, we actually run our IaaS and PaaS services, and we expose them to you through a logical entity called the Azure Resource Manager, which is front-ended by a user experience, which is the web-based portal. And you can target that API either by Visual Studio, by PowerShell, by REST API, and you can actually consume that capacity for all the services that are offered in Azure. Now, if you translate that and see what we are trying to do in Azure Stack, we are literally trying to bring that into your data center. So if you look at this picture, the left-hand side, which actually focuses on what is Azure Stack, you'll see that from the top down, it looks exactly the same. It's the same portal. It is the same Azure Resource Manager that allows you to consume the same APIs from the same styles of tools, Visual Studio, PowerShell, REST API. And then below that, we then start to bring the Azure services, which you can consume through this experience. However, if you go below that, where we say cloud-inspired infrastructure, I can't bring Azure Stack into your data center and tell you to go buy 2 clusters of 1,000 servers each. If I did that, there'd be nobody in this room this morning. And trust me, we've tried this before. Many years back, we had an initiative called the Windows Azure Platform Appliance. And the idea there was literally to take an Azure cluster and drop it to some very large partners of ours. However, the challenge with that is that it's not easy to consume something which is like 1,000 servers, because you have to evolve. You may not know what kind of consumption you're going to have in the beginning. So you need something that you can digest at the size that your company and you can actually deal with. And that is why this time around we've taken a different approach, and we are starting really small. We are starting with as small as 4 physical servers. That's going to be the smallest instance of Azure Stack, or rather Azure, that you can deploy in your data center. And then the benefit of this is that because we have the same user experience, the same APIs that's available in Azure, your customers, your consumers don't have to learn the specific cloud technology you are offering, because we are going to broadcast how you should use Azure. There's going to be lots of training material available for how customers can consume Azure. There's lots of training, certification. So there are lots of your customers who already know how to use Azure. And when you offer Azure Stack to them, you will get the same benefit that they get from going to Azure. So you won't have this dichotomy that your developers or your customers are having to relearn the technology that you are offering from a cloud perspective. So I want to delve a little bit into what I mean by the cloud operating model, right? And this is something that gets lost in noise, but I want to try and illustrate it with an example. And this can apply to Google or AWS as well, at least this part of the slide. So, we are the cloud providers in Microsoft. And so we have lots of engineers and operations people who are responsible for operating Azure in our data centers. And our customers are the ones who actually come to Azure and consume those services, right? Now, when you are getting into the realm of Azure Stack, this is what you are going to take on the responsibility of. So your engineers are going to become cloud architects who are going to design how your cloud infrastructure is going to operate in your data center. And you're going to have a set of cloud administrators who are going to operate Azure Stack in your data center, right? So if previously you were an IT pro, doing System Center, you were doing, VMware, this is your opportunity to really become a cloud administrator. And the good part is that we have tried to make sure that the skills that you have acquired in the past, particularly things like PowerShell, are translatable so that you can become a cloud administrator in the future. And in fact, as we get closer to launch, sometime next year, we are going to offer training materials specifically and certification where you can certify yourself as a cloud administrator for Azure Stack, right? And so our goal is to basically help you make the transition as you and your organizations make the transition to a cloud world. Make sense? All right. And this is unique in the sense that the other cloud providers don't have this approach of a true hybrid platform where they are literally trying to bring a facsimile of their cloud environment into the customer's environment. And as Natalia and Mark and Russ pointed out, or Sinovich pointed out, there are many reasons why customers can't go to the public cloud. And our goal at Microsoft is to meet you in terms of your cloud needs where you need it. If you need it in the public cloud, we have public Azure. If you want to go to a service provider and feel more comfortable, that service provider can deploy Azure Stack and therefore offer Azure services to you. If you want to deploy Azure Stack in your environment, you have that capability with Azure Stack as well. Okay? So I'll focus on a couple of key things today. We'll go through some key design decisions that we took and how we are approaching the delivery for Azure Stack in your data center. I know a lot of you have questions based on when we announced how we are delivering Azure Stack. I'll talk to you a little bit about how you should plan for Azure Stack in your data center. I'll help you go a little deeper into what an Azure Stack system really looks like. And then I'll talk about infrastructure management and the tools and the capabilities that we're going to deliver to you as part of infrastructure management. But I do want to make sure that I leave a good amount of time at the end because I feel that the dialogue and interaction and question answer session is really valuable. So let's try and get through this as soon as possible. So when we started looking at Azure Stack, we had to make a number of key decisions. And this was a slide that was used by Mark Rasinovich as well and Jeffrey Snover on how do we decide what management infrastructure we use in the context of Azure Stack. We've got a great portfolio of tools with System Center. We looked to see if that would be ideal to actually provide to you in the context of the cloud environment. We have got a set of tools that we internally in Microsoft use to operate Azure, right? And then we saw if we could actually take those tools and bring them to you as a part of Azure Stack. And eventually, we realized that the ones that we use in Azure are so deeply intertwined with the way Microsoft operates the data centers that it's not just a matter of giving you those tools. You'll have to operate as per the way we operate. And we can't impose that operating model on you. right? We have our own processes of how we operate, so we couldn't impose that. So we decided, and then System Center, right, has got a great value proposition for Windows Server, and it serves a very dedicated purpose for that. So if we were to start trying to mold System Center to make it fit for what we wanted to do in the context of Azure Stack, then System Center would not be able to satisfy the needs of what it is designed for. And so we decided that we'll take the best of both worlds and we'll create software which is specifically designed to help you operate infrastructure management. But the beauty is that we have learnings from both sides. We've got learnings from System Center, we've got learnings from Azure, and that really allowed us to design this infrastructure software in a manner that's optimal for you to operate Azure in your data center. We then had to make a decision about whether we're going with hyper-converged versus converged, right? And this hyper-converged versus converged really points to whether you're disaggregating the storage or you're actually putting storage into the compute nodes. We look, again, we have a lot of good insight and information about the industry trends, where is storage heading, where is networking heading. And we've got some great technologies in Windows Server 2016. And so to make sure that we have an economical start point for you to start your cloud journey, we settled on using a hyper-converged architecture, using Windows Server 2016. And Storage Spaces Direct, which is a technology that's contained within Windows Server 2016. Then we needed to think about how do we allow you to scale, right? In the past, you were used to saying, okay, tell me how big can a Microsoft failover cluster be? And that became sort of the rallying cry or the debate about how big is us versus VMware. But a cloud infrastructure is not really built like on a single point of scale. Like I told you in Azure, you have clusters which form regions and you have multiple regions. We wanted to allow that same flexibility and scalability for you in your data centers. So Azure Stack has the same scaling model, and I'll talk a little more in detail subsequently, just like Azure. And then the last, one of the interesting decisions we had to make was how open do we want to be in the context of the Hyper-V host and the infrastructure that we run. And the answer is actually really simple. If you go to Azure, can you touch the Hyper-V host? And can you touch any of the management infrastructure that is operating Azure? And the simple answer is no. You can only interact with it through an API surface. And the reason is because in order for us to keep it operational, we put in a lot of effort to patch it, to update it, and keep it stable, right? And so in the context of Azure Stack, we took the same decision, that we'll certainly give you Azure to run in your data centers, but the Hyper-V host will be sealed. The management infrastructure will be sealed. And you will only interact with that capability through a well-defined API and a user experience. So that allows us to make sure that the system can be kept updated, right? But obviously, we recognize that if you're doing that, we have to offer to you all the capabilities that you need in terms of the security postures, to be able to prove that it has the right security posture and so on and so forth. So you'll see how we are making investments to make sure that you can treat it like that and focus on providing value which comes from the Azure services that you want to provide to your customers. And from there, we had to decide what hardware does Azure Stack run on, right? And as a start point, we said, look, we really need to first learn, right? In Azure, in one of the videos I said, Azure is probably the world's largest integrated system because we design our hardware, we actually run hardware, we run validations to every piece of software, firmware, drivers, everything in Azure. And that's how we keep Azure operational. And we had to scale this out. So obviously, we can't force you to buy the hardware we buy. And trust me, the kind of discounts that we get is very different from the kinds of discounts that you can get from your hardware vendors. It's not going to be feasible because you don't buy at the scale that we do. But we still needed to make sure that you got the system in a state that was operational, and it stayed operational in spite of the rapid pace of updates that we are going to provide to you as a part of Azure. Because Azure innovates very rapidly, and you have to keep yourself updated with Azure. Otherwise, your consumers will look at your version of Azure and the real Azure, and they'll say, look, you are not really Azure, you're staying behind. And in order for our team to make sure that we can give you that experience and keep you updated at that pace, we needed to start with a well-known set of hardware. Now, that's a start point. And once we learn from all of you, we'll get better, and we'll be able to use more variety of hardware. And eventually, we might be able to get to a point where we'll say, look, here is the reference architecture, and you should be able to build off of that. But initially, to get you started, to get us that experience, we needed a way to be able to do it in a more, slightly more constrained manner. And that's what you see with integrated systems as a delivery approach. So what does, how is Azure Stack delivered? So it's delivered as an integrated system. And I'll spend a little time about what does an integrated system really mean. So physically, an integrated system means that when you buy Azure Stack, let's assume you buy the smallest unit of Azure Stack that you can put into production. That's going to be 4 physical servers plus 3 physical switches. So when you buy an Azure Stack integrated system, you'll get 4 physical servers. They'll be populated with a bunch of disks, and you'll get 2 top-of-rack switches, and you'll get one BMC switch. And this, one of the great benefits of using Windows Server 2016 is that we can rely on a converged NIC architecture. So we can do storage and networking on the same NIC, because we can actually create a NIC team and a virtual switch using RDMA using Windows Server 2016. And so this is a resilient architecture, with resiliency of the switch. The BMC switch is only required to get to the baseboard management controller, so that we don't statistically believe we actually need resiliency there. That is what an Azure Stack integrated system is. It'll come with the software, right? So when you buy it, it'll come, it'll be deployed for you. It'll be integrated into your data center. It comes with support, so that if you run into any problems, whether the component needs to be replaced, if you run into a problem, you can call and make sure that that system can actually be replaced. And it'll come with a bunch of services, very basic services to integrate it back into your data center, right? So that once it's integrated, that's where your work really starts. How to operate it, how to then make sure that you can provide those services that your customers are going to be asking for in your data center. So when we were building this, we had to look at the entire life cycle. In the past, we've built products where we actually just give you the product and then say, you know what, you need to now go figure out how to actually put it into your data center. Azure Stack is a very different product like that. It's not a product where we just give you the components and then ask you to stitch it together. Azure Stack as a product, right from the get-go, we have gone through the entire details of the architecture topology inside this box. Inside the box of the top-of-rack. So we know how many VLANs we need to set up, because we know exactly the details of the software architecture that we are running. So we can decide how many VLANs are needed to provide the best isolation, right? We have worked with our partners to make sure that you have a variety of different hardware to run on. If you have an IO-intensive workload, you can order a system which has all NVMe devices in it. If you got a CPU-intensive workload, you can go up to our partners and say, you know what, I actually want a system which has more a higher-end CPU bin, right? If you want to have more density of your virtual machines or workloads, you can actually order more memory in your systems, so you can actually get that whatever is required by your workloads, right? And so that's work that we are doing with all of our partners. The next thing is, the software is on the box, but it needs to be integrated, and the final configuration needs to happen in your data center, right? So when the box shows up, you need to provide it power, you need to provide it cooling, and you need to connect it up into your network. And then we'll ask you a series of questions, and I'll walk you through a little bit of tool that will show you what information is required. And then the system will actually be configured to run as an Azure Stack system. So we've put in a lot of investment for the automation that actually deploys Azure Stack, to make sure that it's deployed consistently, and therefore we can update it consistently after that. Validation is a massive investment for us in Azure Stack. And in particular, because if we are going to provide this rapid pace of updates to you, we and you need to make sure that the system remains operational even after an update comes in. How many times have you applied a firmware update to a switch and then realized that your network stopped working? How many? Okay, I guess not many of you update network switches. How many? Okay, let me ask a different question. How many times have you updated Windows Server and then some application stops working? Okay. All right, I was trying to draw attention to somewhere else, but I guess not. it's a fact of life, and it's just a fact of life that it is inordinately, it is prohibitively expensive, impossible to validate all the kinds of applications that run on a rich platform like Windows Server. So in order for us to make sure that when we provide an update to you, that the system remains operational, we've put in a ton of investment to do validation. And in fact, validation will eventually be offered to you as a service in the cloud, where you can point your Azure Stack instance to that service in the cloud and say, I just want you to go poke on me and tell me if my outside-in interfaces for Azure Stack are operational. Right now, we are calling this capability validation as a service. And eventually, we'll open it up to all of you to be able to do your validation and say, I've just applied an update. Just let me know if this thing is working correctly or not. And that will be available to you as a part of the capabilities that we provide to you. We have to make sure that when you're operating it, you can monitor. You can monitor the hardware. You can monitor all the software. You can monitor all the services that you're running in your data center, right? I'm sorry, in the context of Azure Stack. And so all monitoring capabilities are included as a part of the infrastructure software that we are developing and delivering to you as a part of Azure Stack. Security and privacy in today's cloud world is of utmost importance. I mean, there have been numerous attacks. You hear them every day, right? And so we're doing a lot of work to make sure that as Azure Stack is deployed in your data center, it is secure out of the box. And I'll talk a little bit about the principles that we're using to make sure that it remains secure as it is delivered to you in your data centers. Business continuity is a mandatory requirement in many industries, right? And for you as an IT pro, it is that thing that actually allows you to sleep at night, right? Otherwise, how many times do you wake up and say something is down, and if your backup is not there, you're going to lose sleep over that. And so we are doing a lot of work to make sure that we provide that capability as a part of Azure Stack as well. And then patching and updating, right? I mean, patching is every IT pro's challenge and reason for existence in some sense, right? But this is going to be a fact of life for you in Azure Stack, because Azure is going to keep innovating. We have to make sure that we give you those capabilities. And so we're doing a lot of work to provide automation around how you can actually update your systems. And I'll talk in some depth about how that's going to work. And then things are going to fail. I've got people here from my partners, HP, Dell, and Lenovo, and whatever they say, it's not true. Hardware does fail. I'm sure they don't say that anyway, but hardware does fail. And just like software fails, by the way. So when hardware fails, we have to make sure that when the component comes into your data center, right, you're not left stranded trying to figure out how do I now put this component back, right? If a disk fails, we have to provide you all the automation to make sure that when the disk is replaced, everything gets automated and everything is rolled back correctly. If a server is replaced, right, we have to make sure that the boot disk is provisioned correctly, the correct virtual switch configuration is applied, and then it folds back into this, right? We can't just tell you and say, okay, now go figure it out how to make that happen. So we're doing a lot of work with our partners to make sure that when components are replaced, the right things happen, whether it's a physical switch, whether it's a server, whether it's a disk. All that is actually included as a part of our learnings. And we've done a lot of work already with Cloud Platform System. We've got a ton of learning from our partners, Dell, HP, and Lenovo, and we continue to innovate here. Bless you. We've got 3 partners at general availability. We've got Dell EMC, we've got HPE, and we've got Lenovo. And in fact, if you go down to the booth, you can actually go take a look at these systems and touch them. They are actually real. No, they are real. They're not unicorn. In fact, that's the beauty of this. That's the beauty of working with these partners. They've been, it's been such a great collaboration with all these partners. They've brought the best of their engineers to bear, and we've got our best people working together. And our goal is not to make a system which is prohibitively expensive, right? A lot of people think integrated systems, and they think, oh my God, the price of this is going to be very, very high. It is not, actually. If you go down and actually take a look at the systems, they're actually really, they're best of breed servers, but not the sort of gold-plated line, if I may call it that. Like in Dell's case, it's the 730. In HPE's case, it happens to be the DL380. So it's like industry standard servers with their switch lines to make sure that it's fully integrated and validated together. And I'll talk a little bit about what we do as a part of that work. So how do you want to plan for Azure Stack, right? So first of all, I want to talk to you a little bit about how do you think about scale in the context of Azure Stack, right? So first of all, just like Azure, your Azure Stack instances will have one cloud endpoint. That means it will have one URL where your customers can actually go and then consume Azure services that you offer from that URL, right? Now, the services that you offer from Azure Stack is your choice. We will continue to release services, right? Initially, Natalia shared a set of services that we're going to offer, like web apps and CRP and NRP, but more services will keep coming. At some point, we'll add SQL DB. At some point, we may add mobile apps. At some point, we may add, Hadoop or any one of these data services, analytics, or any of these services that are there in Azure are candidates to come on Azure Stack. And it is you and your customers which will drive the priority of which of these services come. But it is really your choice. You can make a decision and say, you know what, in this particular region, I'm more interested in offering only these services because that's the business model that I'm trying to do, right? And it's under your control to decide what services you offer in a particular region, right? Then you can have many regions in your data center, right? And here, in your environment. Here I've chosen a particular environment where they've got a data center in Denver, a data center in Dublin, and a data center in Singapore, and they actually want to offer services from 3 different data centers, right? So that's your opportunity to do that as well. And what I term within that within that region is called a scale unit. A scale unit, when you translate it to Azure terminology in terms of what your tenants see, it is called a failure domain, or a fault domain, I'm sorry. If you actually go to a JSON template for Azure Resource Manager, it actually tells you how many fault domains that template is going to deploy across, right? And so each scale unit represents a failure domain, fault domain, I'm sorry. And it is, in implementation, it is actually implemented using a Microsoft failover cluster using Windows Server 2016. Right? You can have multiple such scale units in a region, and you can have multiple regions in an Azure Stack installation. So your total scale, if you ever want to call it that, in terms of the number of physical servers that you have in your Azure Stack installation, it is the number of servers per scale unit multiplied by the number of scale units in a region multiplied by the total number of regions. That will give you the entire scale of your Azure Stack estate. And at this point, it's too early for us to be able to share what each of those numbers corresponds to, right? But it's reasonable to assume it's a new product, so we're not going to be at like massive scale when we go out of the door. But you should know that our eventual design goal is really high. The eventual design goal to which we are designing to is really high. During the pre-day, I actually shared that number, and I specifically requested them not to tweet it. They tweeted it, so this time I'm not going to say it. So it's a high number that should give you the assurance that you're not going to be capacity constrained with the design that we're going for. And then we'll together work our way to that final design number, right? It's not going to be that massive scale right on day one. Okay? So now that you've thought about scale, then what are the other things you need to consider when you want to bring Azure Stack into your data center? First of all, you need to evaluate what is the purpose that you're getting it in for. If you're just firstly trying to understand what Azure Stack is, help your developers, help your customers understand what Azure Stack is, you can actually get a single box instance like we have in TP2. And it's any off-the-shelf server with 128 or 96 gigs of RAM, 12 cores of CPU, and 5 or 6 disks will serve the purpose. And we've got the specs up there on the sheet. So you can get a single box server installation for Azure Stack, and that will install all the capabilities in Azure Stack. It will not be resilient, not for production purposes, but it allows you as a customer and your customers to actually figure out what can I use Azure Stack for. And if you want to deploy more Azure services, just beef up the server. Give it like 512 gigs of RAM and lots of storage, and you can deploy as new and new Azure services come in. So my guidance to all of you would be that all of you should have one of these servers under your desk so that you can constantly try and understand what's coming in Azure Stack, what's new. I have one. I got mine recently. It's great having it there. In fact, my demo that I'm going to show you is actually running off of that box. And I deploy Azure Stack almost daily. As it comes out, I do it in 2 hours, I'm done. I've got an Azure Stack installation, and that allows me to really understand, what did the team do last night. Sometimes it's good, sometimes it's not so good. The second thing you need to understand is, if you're really going for a production system, then you need to start having a conversation with the 3 partners. Dell, HP, Lenovo, whoever is your vendor of choice. Start to have a discussion about, where do you want to deploy, which regions, which countries. Start to understand the details of that, right? And if you go later today to Spencer's session, he'll talk a little more in depth about, the architecture of what's inside those Azure Stack systems as well, by the way. Then you need to understand, before you go tell the partner how big of a system you want, you need to understand what Azure VM sizes do you want to offer, right? Remember, Azure Stack is Azure. So you're going to offer the same VM sizes that are available in Azure, and you have to decide which ones you want to offer. It's your call, right? You have to decide what Azure services you're going to offer in your data center, because that will dictate how big of a box you need. You may need more CPU, you may need more memory, you may need more disk. So you'll have to go understand all of that. Then you need to understand what kind of a workload are you deploying in a data center. Is your customer workload going to be IO intensive? Well, in that case, buy a scale unit which has got NVMe devices in an extreme case. If you think that you can actually, if it's not that IO intensive, you can Azure Stack supports a tiered storage architecture where you can have a caching device using SSD and backed by hard disks. So you can do that approach as well, right? If you want CPU intensive, go for the higher CPU bins, go for higher number of cores. And then depending upon, again, capacity, you can increase or decrease the amount of memory. And I'll talk a little bit about what's the lowest scale that we support in terms of memory, CPU, and so on and so forth. And then you have to decide, how many regions do you want to be and how many scale units you want in each of your data centers. But like I said, you can start as small as 1 region with 1 scale unit only of 4 servers with 3 switches. That's your smallest instance. And then you need to decide, what kind of an identity subsystem you want to use in the context of your tenants, right? There are benefits of using one versus the other. If you use Azure AD, then your tenants need to be federated with Azure AD, and that's how we will get a token and authenticate ourselves to the portal. If you're offering services to an internal organization, you may choose to just use ADFS using an internal Active Directory forest, federate with ADFS, and they can actually get a token from ADFS and then log into the portal in that manner. All entirely up to you, right? So now that you've got this, now the system shows up in your data center, right? Now what else needs to happen in terms of integrating in your data center? I've grayed out the actual scale units. So let's say they've sat in your data center. First of all, you need to provide them space, power, and cooling, right? And specifically the real estate facilities people who are responsible for putting it into the data center, they have all this, our partners will provide detailed information about what's the space requirements, power requirements, cooling requirements, and so on and so forth, right? Then you need to think about how am I going to integrate this into my network, right? Because this is going to come with its own network switches, right? So the top here actually shows your border devices. This is your border devices. Whatever devices you have. You could have Cisco, Juniper, whatever is there in your data center. Using standard protocols, right? Our network infrastructure that is inside Azure Stack from the top of rack / aggregate switch will then need to plug in to your border devices, right? And there's a clearly defined set of information that we will gather to actually do that border device integration, right? And then you need to, once you've done that, then you need to make sure that, you as administrators will need to be able to log into Azure Stack and operate Azure Stack, right? And then in order to do that, you're going to have some sort of an identity subsystem in your data center. We come with our own Active Directory inside Azure Stack. And so you need a one-way trust to be established from your identity subsystem into the identity subsystem inside Azure Stack. And then you need to decide, how are you going to monitor the system? It has its own monitoring capability, right? But maybe you don't want to look at that particular console that's there in Azure Stack. And maybe you've got a central monitoring system and a ticketing system. So you can basically take all the alerts that are generated from Azure Stack and integrate it into your data center, right? And you can do that for ticketing and things like that as well. So I'm going to briefly switch to my system and just show you, a sort of a spreadsheet of information that you will all right, so here is a spreadsheet, right? And this spreadsheet is going to ask you all the information that's going to be required when you need to actually deploy an Azure Stack system, right? So this spreadsheet will be made available to you closer to GA when it makes more sense. But the idea is that this will come to you way before the system comes to you, right? So you can go gather from your networking team the information that's required. You can decide what you need to call the domain that's going to be there inside Azure Stack. And all the information that's going to be required at the time of deployment is actually needed to be gathered in this, including things like network settings, right? This has a very nice picture here as well, which will show you, like what kind of a network environment is needed to be set up, and pictographically it will very easily allow to tell you what information is required to be gathered for Azure Stack. Does it make sense? So now that you've gathered all this information, you'll be able to feed it into the deployment engine that comes as a part of Azure Stack, and that will actually go lay out the system and integrate it back into your environment using this functionality. All right. Okay, that's not good. All right. So now let's go into the box a little bit to see what's there actually inside the box, right? So logically, right, there is an end user experience, there is a portal, right, over which the services are offered. We have the unified application model, which is exposed through Azure Resource Manager, and then you have an extensible framework into which services are deployed. You have a bunch of foundational services like compute, storage, and networking, and then you can deploy additional services like Azure Container Service and SQL DB and all these services, right? They'll all rely on those foundational services. And those foundational services live on that, yeah, they do love it too, but they live on that underlying cloud infrastructure, right? And so let's dig into what that really actually looks like. So if you go deeper in, what I've tried to do here is all the things that are there in red are the things that are relevant from an infrastructure management perspective, right? So at a very high level, in Azure land, a resource provider is what allows you to communicate with the underlying resource and has a user extension that allows you to actually consume it from the portal, right? So we have a fabric resource provider, a health resource provider, and an update resource provider. These are what provide information about the fabric, health, and update are surfaced up into the UI, and they underneath actually have actual code which actually communicates with the underlying infrastructure, right? So each of these RPs actually have a northbound interface which plugs into the portal, and they have a southbound interface which actually does the real work of talking to the physical machine, talking to various components inside the software, or it's responsible for update. We've got an automation engine which right now we are calling infrastructure deployment. This automation engine is included as a part of Azure Stack, and that is the one that actually does the hard work of doing the deployments and doing the automation of the updates and so on and so forth, right? And then if you actually go into the infrastructure roles, you'll see that there is a whole lot of things that we need to deploy in order to make sure that Azure Stack is operational. So we've got directory here. We need to make sure that certificates are rotated. We've got the compute controller, the edge controller, the network controller, the storage controller. We have things in there which allow you to manage the physical machines. We've got an internal data store where we actually keep all our data included as a part of all of this. We've got a piece of software which does update management. Again, I'm sharing this with all of you so you understand, but you don't have to worry about all of this because this is all internal to the guts of how Azure Stack infrastructure management operates. Make sense? And then everything layers on top of this, right? And so if you want to go deeper into what this actually translates into a physical unit, right? As I showed you earlier, the smallest unit is 4 physical servers with 3 switches. And I've given you a brief idea of what the minimum spec for a server will look like. It's going to have 2 10-gig ports, right? Most partners will be just end up picking 1 physical NIC with 2 ports, right? Minimum requirement is 256 gigs of memory and minimum of 8 cores and a minimum of 2 CPU sockets, right? And then again, it's up to you. You want something that's more powerful, go for 16 cores and 2 sockets, right? If you want something, even more, go for 16 cores with 4 sockets. You want more memory, go to 512, go to a terabyte, right? You want higher networking, go to 240 gig ports, right? So all this is actually within the realm of what you want to be able to do. Then we require one boot media, SSD. That's where you actually boot off the hypervisor from. And then you have 2 caching devices and 4 hard disks. That's the minimum requirement, but it's up to you. You can actually have all 6 as NVMe. You can have all 6 SSD. You can have more SSD, less disk. And again, those are all things that you need to have a discussion about your own requirements and then actually talk to your partner about how to make that happen. I want to be, just transparent in the sense that, look, as we learn more, we'll get better at being able to offer more of this diversity. Initially, we may be a little constrained, but I think as we learn more, we'll be able to do a lot more diversity in terms of these capabilities. And then each server actually runs Windows Server 2016 Hyper-V. That's how we actually partition the system. And these servers are all aggregated together in a hyper-converged cluster. That's what actually works, provides the storage layer as well as the hypervisor layer. And then we deploy everything in a resilient manner, whether it is Azure Resource Manager, whether it is the portal, whether it is each of our own components. They're all deployed in a resilience manner. And the resiliency depends upon what that component is. So for example, portal and Azure Resource Manager, they're web properties. So they actually sit behind a load balancer, which is also included as a part of this, because Windows Server 2016 has a software load balancer. So that also handles all of the software capabilities for load balancing across those web properties. Okay? Now let's delve a little bit about what is our vision for infrastructure management, right? The goal really is that you as cloud administrators will operate and troubleshoot across all of the infrastructure, right? And you have a single point for management, which is surfaced through the same user experience that you're used to seeing in the context of Azure or even Azure Stack. The user experience will be the same. And the goal is to provide management in such a way to you that you can focus on providing the SLAs that are responsible for your business, right? And our goal is that a single administrator should be able to manage a 4-server instance very easily, and possibly even higher. So you don't need to be specialized in networking or specialized in storage. If you are specialized, that's fantastic. But we really want you to be able to sort of work across all these domains and be able to administer the system in your environment. So what does infrastructure management provide? It's a web-based experience. You can either access it through the web, through the portal, or you can actually manage it using the REST API or through PowerShell. It allows you to monitor your systems. It allows you to patch and update your systems. It has experiences in there for you to be able to run when you want to replace components in your data center. And it also allows you to do plans, offers, and user management, which is required for the back end of all the services that you offer up into your customers, right? Let's go a little bit deeper to say, how is this actually achieved? So I talked to you about the 3 resource providers. You have a Fabric resource provider, you have a Health resource provider, and you have an Update resource provider, right? Each of them have a northbound API, which exposes the REST API to ARM and Portal, and they sit behind the same RBAC model that ARM offers. So when you log in, right, if you're identified as an administrator in Azure Stack, you will get to see a set of experiences that you have been given access to. If I'm not an administrator, I won't actually see any of those experiences. However, if I have been granted rights as an administrator, I'll be able to log in and see those experiences that's required for administering Azure Stack. Right? So let's do a quick walkthrough. I seem to be having trouble getting back to my server. If it comes back, otherwise I'll go back. Not bad. Good. All right. So first of all, I'm logged in here into the Azure Stack portal. But if you actually see, this experience is different from what you log in when you get a tenant, right? This is an administrator. So I'm happen to be logged in as an admin for this particular infrastructure. And I can actually see a bunch of resources which I won't if I log in as a tenant. You remember I talked about the concept of regions? This particular Azure Stack instance happens to be deployed in one region. If you had multiple regions, each of those regions will show up as a line item here, right? So let's take a look at how do I administer a particular region. So I can click on this region, right? And I get a user experience that is tailored to that particular region. So each region will have its own instance of the Fabric resource provider, the update resource provider, and things like that, which is how ARM and Portal are getting that information and then exposing it to you in the context of this user experience, right? So here you are seeing, in the first thing you'll see that you'll see what kind of alerts are available. Now, this is TP2, so we haven't implemented this thing called system health tests, but I'll share with you what this means. Then you have a whole bunch of infrastructure roles. You know, in this case, these are all the roles that you actually saw in that red box previously, right? So the directory, Azure Consistent Storage, the health controller, storage controller, infrastructure deployment, Azure Resource Manager. These are all the resource provider which provide functionality up to your consumers. And if you add additional Azure services, they will all show up here in this list. When you have SQL DB and others, they will all show up as resource providers here, which offer tenant-facing customer services, right? So let's drill into one of these and see what it looks like. All right. So what we've tried to really do is that for each of these experiences, it is consistent regardless of which particular resource provider you pick, right? And what I mean by that is if you look at this particular blade, which is now giving you information about storage, these two blades, or these two tiles, I'm sorry, will be common for every resource provider. So, you know, you as an IT pro, you can train yourself to understand that each time I open a blade, these two things will tell me what are the alerts that are specific to this particular resource provider, and how is the health of this particular component being reported based on the system health tests, right? And the system health tests are a series of synthetic tests that run continuously against this particular component to test its health, right? And then below this line, this particular tile is specific to this particular resource provider, controller. And in this case, this happens to be storage. So you're seeing that the total amount of capacity that I have is 1.4 terabytes, out of which I've actually used only 256 gigabytes, right? So you'll be able to very quickly ascertain what's going on in the context of this particular environment, right? And similarly, you can go back. Right? And then you see here, you'll actually have an update tile, but I have a separate demo where I'll talk a little bit about updates as well. But this is sort of at a very high level, the portal-based experience that you have, right, as a part of this. One interesting thing I do want to show you is, I'm clicking on the alerts tile, right, and I happen to have an alert here, because this morning what I did specifically to generate this was I shut off the WSUS server. So I got an alert saying, look, your WSUS server is offline, you need to figure out what you need to do. But here's the interesting part, right? For those of you who use VMM, we actually implemented a capability where you can actually see the API call that you need to make so that you can actually invoke this from PowerShell or any other tool that can invoke a REST-based API. So if you don't want to use the user experience here, you want to use PowerShell, you want to use Python, Perl, whatever your language of choice is, you can actually just pick up this REST API call, plug it into anything that can make a REST call, and you'll be able to extract information for this particular blade that you're seeing. Make sense? All right, let's get back. All right, so how does Azure Stack Monitoring actually work, right? So like I said, Azure Stack Monitoring, I apologize for the slide, it moved around a little bit. But really there are two parts to this. First of all, we measure the health of a component in two ways, right? First of all, each component has its own notion of health, and it will report based on that and saying, look, I think I'm healthy or I'm unhealthy. Like for example, we recognize that the WSUS server is turned off or off, and I'm saying, look, that thing is down, something is wrong, we need to go figure out and diagnose what's wrong with that system, right? The other thing is, for all the components, we will run external in system health tests. So how this component is actually used by the rest of the system, some synthetic test will use it in the same manner, right? Because that's the best way to tell. How do I know if my mouse is working, right? I click on it to make sure that I can move the mouse around, right? So that's the same notion in the context of each of these components. The way the component is used by somebody else or any other component, we actually test that particular interface. And if that does what it's supposed to do, then we report whether that component is healthy or not healthy. And then if it's not healthy, then we raise alerts. And the goal is to not flood you with alerts. We're doing a lot of work to make sure that we constrain the number of alerts that we raise so that you can actually take specific action on that particular alert. It's not just some random alert which says something happened and then you have to Bing it or Google it or whatever your choice of search engine is, figure out what's going on, right? So that's not the intention. This is probably one of the biggest investments that we've got in Azure Stack. First of all, our goal is to be able to give you an update a month. And our goal is for you to be comfortable to take that update a month, right? It's a tall order for us. I don't think we've been very successful in giving you updates and giving you an assurance. Today, when you go patch your infrastructure, you're nervous, and rightfully so. So we, in our own internal labs, are now getting to the point where we're going to update ourselves almost daily, so that we do the engineering work up front, so you get that automation that goes along with all the updates. So if you actually look at an Azure Stack update, it'll contain the payload of updates, all the updates, which include all the firmware, the BIOS, the drivers, operating system updates, anything else that's required to run Azure Stack. They'll all come in one update, right? And it will also contain an automation framework, which will then automate the application of that framework, of those updates across your entire infrastructure without bringing down your tenant workloads. And the way we do that is pretty simple, actually. It's a Hyper-V cluster, so we can actually live migrate anything off of the Hyper-V host, drain the host, apply all the patches to that system from drivers all the way up to the OS and other software, bring it back into the pool, and then we rotate around like that, right? But there's one interesting thing that we are doing. We actually don't update the hypervisor host itself. We actually just re-image it. So each time we do it, we just, on the stamp, actually, we construct a new VHD or VHDX, and we just point it onto the physical host, and then we flip the boot order. And we boot to a new VHD with all the new VHDX, with all the patches, and then we actually just go through and reconfigure it based on the information that we have available to us. And in fact, that's why all Azure Stack systems will boot from VHD. They will only boot from VHD, because that's the easiest way for us to be able to flip and patch. In fact, even your single box system that we give you in TP2, boot from VHD. That's the best way to get our patches, flip it around really quickly, and go forward with this. Make sense? Then, what are we doing for backup and disaster recovery? The most important thing you have to recognize is, just like in Azure, you have to think of this separately. One is, what do we do in the context of backup and recovery for what's going on in the tenant space, right? And then what are we doing to ensure that the underlying infrastructure is also safeguarded? On the tenant space, you'll be able to use a variety of services. We have Azure Site Recovery for tenant DR. We have Azure Backup Service to be able to do backup. If you don't like that, you can install any third-party software into a virtual machine like Commvault or DPM, point it to your other assets, and point it to some on-premises storage, and you'll be able to store your backups there, right? So the tenant space is very similar to what you would get in Azure, right? Now, there will be a question where some of you will ask me and say, well, I actually want to run the Azure Backup Service in my data center. We've heard that feedback, and we are looking to see, it's another Azure service for us. So we'll get that service, on premises over time as well, right? So that's what we do in the context of the tenant space. On the infrastructure space, we actually have an infrastructure backup controller. And what the job of this infrastructure backup controller is to talk to each of the components and tell it, I want your backup state, and then squirrel that state off to a file share external to Azure Stack. And then that file share is just data. And then you can use whatever you want to back up that file, data on the file share. You can just make copies of it. You can use any third-party software to back up the file share and keep that data. And then when you want to rehydrate it back, just get the data back, give it back to the infrastructure backup controller, and it will go back and actually put the systems back in shape, right? So that's what we are trying to do in the context of backup and disaster recovery. Security is a huge investment for us, right? We've learned a lot with CPS on when we get into these large environments and customers, what does security actually mean? This is not about saying I've got a security feature. This is about securing the estate of Azure Stack end to end, from the portal to make sure that we've got pen tests, to make sure that the web properties are safe, to make sure that no malicious user can walk into the data center and walk out with a physical disk with valuable data in it. So all data will be BitLocker. So even if you walk away with a data disk, it's going to be encrypted. You're not going to be able to get anything out of it. From an administration perspective, we are using capabilities like GIA, which allow us to constrain that once you come in to do a particular task, you will have access to be able to do only a certain set of tasks. You won't have access, like if you log in as an admin into Windows today, you can do pretty much anything, including delete the C drive, right? But our goal is that when you come in to do any administrative task in the context of Azure Stack, let's say I want to reboot the WSUS server. I'll be constrained in what I'll be able to do in the context of that role that I'm coming in with. So I'll be able to do 4 or 5 tasks, and that's it. So I'm protected from being able to do like that, right? We've got some fantastic capabilities, which allows us to whitelist what runs on the Hyper-V host. So we'll constrain what runs on the Hyper-V host. That way, if even maliciously something shows up there, it'll be prevented from actually running in that particular environment. And then we recognize that we have to have a good audit trail so that you can prove to your auditors for HIPAA compliance, PCI compliance, FedRAC compliance, understanding what are the audit trail of all the activities that were taken in the context of this Azure Stack, right? It'll have a secure OS baseline. A number of people come up and ask to me if we're actually going to use Nano. In the initial release of Azure Stack, we are not going to use Nano. We'll be using Server Core as the Hyper-V host and all the VMs that are hosting our infrastructure. But over time, we'll be able to make a transition to Nano. We'll disable all legacy protocols like NTLM, which are considered insecure. And it'll be configured with antivirus configuration right out of the box. So all the infrastructure, we'll make sure it's all hardened, set up, ready for you. So you can really focus on saying, how do I keep it updated? How do I make sure it's running? But really focus on those Azure services. That's what your developers are going to ask you for. That's what your consumers are going to ask you for, right? So I'm going to show you a little bit of a demo on monitoring on patching. Let's go back to the system that we were on, right? So if you go back here and actually look at the first blade, here, if you actually see, right, you actually see this information about that a new update is available, right? Now, this actually does not require your Azure Stack to be connected to the internet. I just want to be clear. You can have it connected to the internet, but what really has happened behind the scene is that you as an IT pro, either we published a KB or something, you realize that a new update is available, right? You downloaded that KB, and maybe on a different laptop, completely air-gapped, right? You downloaded it, and you put it into a specific location in Azure Stack, right? The moment you do that, the UI will pick it up and say, oh, I've got an update that's available. Now, if you're connected, we may consider giving a different experience where you can automatically get this. But initially, our goal is to say, look, you're air-gapped, you can download it, just put it into that location, and it will say, okay, a new update is available, right? So it's under your control. You decide when you want to do this update. Right? Now, once you do this, right, let's click on this and see what happens. Okay. So it will tell you that this particular update is available. It hasn't been started. And you can actually just click on this particular update, right? And right here, all you need to do is update now, and all that magic that I showed you, infrastructure controller, CRP, NRP, network controller, load balance, Windows Server, all of it, firmware, drivers, everything will be updated with that switch. It'll be all automated behind all of you. Somebody wants to clap. Please go ahead, you're more than welcome. It'll all be updated as a part of this capability, right? Now, the one thing we don't automate right now is the updating of physical switches. However, we and our partners will provide clear guidance and documentation on how to actually do the updates even for those physical switches, right? So that even when a physical switch is being updated, none of your tenant workloads come down because that patching is taking place. But the rest of it will all be automated. Now, like I said, our target is to get you there to do a monthly update. Where we will be when we actually GA largely depends upon how good we are at that point of time. But we are not going to, if we are not good, we'll say, okay, we'll drop to 2 months. till we feel confident that we can make you do it confidently, we're not going to release an update. And that's the tremendous amount of work that we and our partners, HP, Dell, Lenovo, and us have to do. I've got like racks and racks and rows of hardware where we actually run this validation continuously to make sure that it is updated. And we know, because we know you're going to have the same systems. That's how we can make sure that we can keep you updated. We can update the drivers. By the way, how many of you know that there is firmware that runs on the physical disks? Do you know that? Great. For the rest of you, there is software. You will be surprised how much software actually runs under the operating system that needs to be updated. There is firmware on the disks. There is firmware on the disk controllers. There is firmware on your NICs. There is BIOS. There is BMC. All this software interacts very closely with the storage subsystem, with the operating system, with the networking gear. That has all to be updated to make sure that this whole thing works like one system. And so that's all the work that we are doing as a part of this to make sure that we can update it. Now, I'm not trying to sort of, yes, it is a complex system. That's part of the reason why we're actually doing this. And Azure has the same interesting sort of challenges that we have to solve for our customers. And we do that in Azure as well. Okay? So the question is, who's going to provide the updates? We're working through that detail. But the idea is that when it shows up in your environment, you'll get one payload. Whether it comes to you from us or them, at the end of the day, you'll end up with sort of one payload, if you will. Okay. One other thing I wanted to show you was monitoring. And we've actually briefly seen that already, but I just wanted to go through this once again. So if you look here, as you logged in, the first thing you saw was that there was a warning in this environment, right? So if you happen to click on this particular warning, right, you'll get a list of all the warnings that are out there. And this one very clearly says that, my WSUS server happens to be unreachable because there is a heartbeat, which we actually do with all of our components that are running to make sure that they are operational. This one happens to be off. This one happens to be off because this morning I came in and actually just PowerShell the thing out of it. I shut it down. Obviously, you won't do that intentionally. But the idea is that when you do something like this, you'll see a clear, actionable alert. And then you as an IT pro, as an operator, can go figure out what to do and bring that system back upline, right? You'll also get alerts like, for example, the storage subsystem is resilient. So a disk may fail, but the whole system won't come down as a consequence, right? But you need to then order a replacement disk. So you need to then pick up the phone or whatever your support channel and say, look, I want an additional disk to be replaced. And then when it comes in, you'll have a clear set of guidance on how to replace that particular disk or that particular component so it comes back into the fold. Okay? All right. All right, so very quickly, what are the timelines for Azure Stack? Natalia shared this as well. We've released Technical Preview 2 right now in September. It was so difficult. On Sunday, we had pre-day. And we were not allowed to share the date. And it was so difficult for me not to say it's coming out tomorrow. But now I don't have that problem. It's out. You should go try it right now. We'll do a technical preview 3. I expect it to land sometime in early next calendar year. And then the goal is to have Azure Stack generally available with hardware at calendar year 17. Now, a number of people ask me, well, okay, you will GA, but when will the hardware be available? Well, the fact of life is that there is no GA of Azure Stack till the hardware is ready. The GA of Azure Stack is coincident with the availability of that hardware. Now, obviously, we're not going to tell you that you can start buying hardware only when we GA. Sometime before GA, our partners will say, okay, now you can actually start pre-ordering your systems for Azure Stack so that you can be ready to go right on day one, right? And like I said, we've got a private preview going on for the integrated systems right now, so we can get some validation. We're actually going to deploy, a fairly significant number of them globally to really get an understanding of how the update cycle works, how the support cycle works. All of that is going to be flushed out. And then we'll actually do a mid-calendar year 17. Like I said, it's coincident as a part of this. So to summarize, Azure Stack is going to be delivered as a pre-validated integrated system. There is a ton of validation that we are going through right now, and there's a ton of learning that we have to get from all of you and us together as we are on this journey for getting Azure into your data center. It contains purpose-built infrastructure management capabilities for monitoring, for health, for alerting, for updates, for patching. All of this is included as a part of Azure Stack, but has a way for you to integrate into your data center using a REST-based API or PowerShell. You can start understanding what capabilities are available now in TP2. Some elements of infrastructure management are already available. In fact, I was running TP2. You can understand the REST-based APIs. You can start to understand what the user experience looks like. Give us feedback on what you want to see as a part of this infrastructure management capability, right? And then lastly, Spencer's session on architecture is overrated, and Charlie and Thomas were hell-bent that I'm going to steal their thunder. But don't believe me, go to their sessions. They are a great set of people. You must go to these sessions. Spencer actually has a session called BRK 4019. He goes further into the architecture of Azure Stack. He'll go into the depth of the hardware, how these things interact, how the clusters are set up, all of that if you want to go in there. And then Charlie and Thomas later today, I beg your pardon, they have a session on Friday, BRK 3115. This one focuses more details on if you want to integrate, the demo that I showed you about the alert, if you want to really understand how that integrates back using an API and a demo, go look at that system. We've got about 10 minutes left. That's the end of what I wanted to say, but now I want to open up the room for questions. Yes. Thank you. Please use the mics so we can, if not, I'll try and repeat the questions, but go ahead. Yes, please go ahead. So the question is licensing. Great question. We are not in a position right now to share information about licensing. We will share more information about licensing as we move along.
Vijay?
Yes.
Yeah. Hi. We are an early adapters of the cloud platform system. We're using the portal. So come see an interesting session. I'm not trying to sell the session. Come see us at the 12:30 at C113, I guess. But the question is, it's really related to the data center integration. It's to the network integration. And I noticed Microsoft is proposing connection to a border switch. Lots of new data centers now, they use spine and leaf. You want to be part of the fabric.
Yeah.
To connect to the border, it will give you an extra hub. You want to eliminate it.
Yeah.
So I would recommend Microsoft talk to the switch vendors.
Yeah.
And make sure those switch vendors talk to the main providers of switching and routing at the data center. I ended up connecting at layer 3, no dynamic, floater static, still working for me for the backup, for the redundancy, but that's not really ideal because I went ahead, I bought the technology without communicating with my network team.
Okay.
So really a good advice is talk to your network team before you make any move.
Perfect. Thank you. So I just reiterate what he just said. He said, look, we're actually using a lot of data center using leaf-spine technology. In fact, we are a leaf-spine system actually even within Azure Stack. So we understand that, but your feedback is really valid. We should make sure that we integrate into the leaf-spine architecture. In fact, Eric Marquez here is the guru here for Azure Stack physical network integration, and so that feedback is well taken. Thank you so much.
Next question here.
Yeah.
For monitoring, can you explain the scope of monitoring that Azure Stack portal/software provides, and whether or when would customers need to use System Center or OMS to do more advanced monitoring? And then the second question is there any partner software on the systems, like does HPE or Lenovo have their own?
You're John Ayub, right?
Yeah.
Okay, great. Okay, so so question is, what third-party software exists? So first of all, hardware monitoring is not natively included in Azure Stack. So I think HP is planning to do some work integrating with HP OpenView. So that's how they'll. But again, they will not have any agents on the Hyper-V host. They will do all the hardware monitoring through the BMC. Similarly, Dell will integrate into the Dell Open Manage, and they will again do it from the BNC and up there. If you have, and a lot of these partners also have SCOM integration, for hardware monitoring. So you can put up System Center external to that as well for hardware monitoring. Um, uh, sorry, Thomas, did I say something wrong?
No, it's just we're going to cover that in the session on Thursday.
Okay, I told you they're not happy if I steal their thunder. So, so go to their session. That's BRK3115. I'm not going to say anything more. But hardware monitoring is not included within that, right? OMS is not required for managing Azure Stack. However, we are looking to provide advanced scenarios that you can actually do with OMS. And there is a fundamental rationale behind this, because if Azure Stack is to provide you capabilities so that you don't have to connect to the public cloud, and I go build a management story that requires you to use OMS or requires you to do something else, then I'm failing in my responsibility on giving you an Azure Stack instance that doesn't have to connect to the public cloud. However, OMS is a great capabilities, has some great capabilities for security detection, intrusion detection, and for log analytics, and we are certainly exploring advanced scenarios to be able to use those OMS capabilities. But no agents on the Hyper-V host, no backup agents other than nothing on the Hyper-V host. That's the only way we can make sure that we can keep it updated. We have our own software, but that's it. That's locked out. That's the sealed host approach. Yes?
Yeah, hi. Will multiple regions be supported at GA?
So the question is, will regions be supported with GA? Now I'm going to have to dance. Like I said, the thing is, what scale we will be at and whether we will support multiple regions and all are all something that we're working through. We are, about 8-9 months away from GA, so it's too early to tell where we'll land at that prototype. But certainly way before GA, we'll tell you. And the good part with the Azure Stack is that it's not a static entity, right? There'll be something that will be at GA, and 3 months later, you'll get something else, and 6 months later, you'll get something else. So even if something is not available at GA, your feedback is what counts. We'll keep adding and validating capabilities. Yeah. But the most important thing for you to recognize is that architecturally, we are set up for multiple regions and multiple clusters, multiple scale units, I'm sorry, right? There is no fundamental architectural change we have to make. It's only a matter of actually doing the validation and the engineering work to get it out of the door.
Yeah, thank you.
Sure.
If I'm not mistaken, 3 years ago, Microsoft came out with R2 2012 and system-centered R2. At that time, the message was about Cloud OS, VMM, private cloud, systems. So I see big overlap with Cloud Stack, or Azure Stack, with what was at that time pitched with VMM and system and private cloud. So is the direction actually deviating? It dead? I mean, what's the development there?
Great. So it's a great question. So actually, the direction is not deviating. We've been, talking about the cloud, both public cloud and private cloud, for a while. Previously, if you looked at, 2012 R2 era, the way we offered cloud was we actually took Windows Server 2012 R2, we put System Center 2012 R2 on top of that, and then layered Windows Azure Pack. And we provided a notion of Azure consistency like that. But when we actually dig down, we say, look, a lot of customers don't want some simple, VMs, the ability to create VMs using a self-service portal. They want literally Azure in your data center. So this is, on-prem cloud Gen 2, if you will, which really focuses on providing as close to Azure as we can possibly get. So it's not a deviation, it's an evolution of our story. And of course, if you are just focused on providing virtual machines, there is a ton of capabilities that's there in Windows Server 2016, System Center 2016, and Windows Azure Pack, which is also supported on top of 2016. If that's what you want, then that's a path for you as well. We are trying to make sure that we give you all the flexibility. But if it's Azure what you want in your data center, then this is the product, Microsoft Azure Stack. Yes? Sorry, how do? So the question is, how do ingredient providers like SSD, NIC providers, and how do they participate in Azure Stack? So for those of you who are familiar, we actually have a hardware logo kit. The HLK actually has a whole series of tests which are included in there specifically for Azure Stack. And if you participate in that, you'll be able to make sure that the components are ready to participate in an integrated system that's being developed by our partners and us. Yeah. Other questions? Yes. It's a great question. He's asking, Patrick is asking, how prescriptive are the integrated systems? Are we going to mandate, for example, that you can have only 6 disks, and if you go to the 7th disk, you're out of luck? It's not prescriptive like that. It's prescriptive in the way the topology is laid out. It's prescriptive in, the sort of the componentry that you use. But numbers and variants, that's really between, the customer and our partners. There is an aspect of that we have to make sure that we do the engineering work to be able to handle all these variations. And that is something that's just an engineering thing, how we get to it, but that is not our intent. That's not prescriptive. You want to go with all flash? Sure, go ahead, by all means. You want a different CPU bin? By all means, go ahead, right? But, the one thing, people will say, look, but I want this system with, I don't want to use the blast switch, I want to use the blast switch. That is going to be problematic because there is deep interaction between the physical switch that's included as a part of Azure Stack and the networking NICs. There's prescriptive configuration that needs to be done, and that we are very prescriptive about. But other than that, you want to go with a higher bin CPU, more memory, less memory, more storage, all within realm of discussion. Networking, the physical switches are sensitive, but everything else, it's a matter of us getting to do engineering and validation with the partners. If you want, like I said, all flash, all disk, all doable. Any other questions?
I have one. Sorry.
Yes.
One other question. So if there's going to be third-party partner software on any of the 3 models, so I guess I'm trying to make sure I understand. Does Azure Stack push the firmware update, or does the third-party software do that? Is it done?
So the question is, how is the firmware updated? And the short answer to this is, you don't need to worry about it. We'll figure it out for you, right? That's not really, because if there is any third-party tool that's required to flash firmware, it'll come to you as a part of the payload. The automation will boot into an operating system where I can run that particular instance of the tool, flash the BIOS, and do all the work. So you don't need to worry about it. So the short answer is, don't worry. You've got a lot more to worry. Let us worry about this stuff. You've got a lot more to worry about. Keep it operational. Focus on the value that you provide to your customers. Focus on how you integrate into your data center. Any other questions I can answer? Yes. So the question is, will the VMs that you create on Azure Stack match what is there on Azure? So I just want to make sure I'm answering the right question. We create a bunch of VMs for Azure Stack infrastructure management, right? That is separate. That's whatever sizes we need. But the VMs that your customers can create on Azure Stack will be the same sizes that are available in Azure. But it is for you to decide which of those sizes you want to offer in your environment. Because if you go to the D sizes, the DS sizes, they have big requirements in terms of memory and storage. So you're going to have to make sure that the systems that you acquire have the ability to actually do that. But they will be VM sizes in Azure. And the right way to ask the question is, why is it like that? Well, because this is Azure. This isn't anything like Azure. This is Azure. And therefore, you get to run only the VMs that are there in Azure. Yes?
The servicing, are you reserving a node? If you take a 4-node system, are you reserving a node to allow you to move workloads across?
Yeah. No, so, and again, Spencer is not worried about me stealing his thunder, but still, you should go to that session. But you're right, in the 4-server system, what effectively we do is we actually take one server and we keep that as reserve for failover, as well as for making sure that there is enough capacity so we can move VMs around when we actually need to do an update. Yes?
The View API functionality, is that available for all resources?
The question is, View API functionality, is it available for all resources? Not in TP2, but in TP2 there are only some blades that actually have the View API, but we're working to make sure that happens over time. Yes? So the question is, obviously the software that you are running in Azure Stack, I'm paraphrasing a little bit, like ARM and Compute Resource Provider and so on and so forth, they consume some capacity. So how much of it that they consume? I should have actually, it's a great question, I should have put that in my deck. On a 4-server system, roughly we consume about 1 server worth of capacity. For Azure Resource Manager. Yes. We consume about that much of capacity. And then we'll be able to operate up to a certain scale point using that much, and then there'll be a stair-step function that beyond a certain scale we might need to use more. But that should get us to a fairly significant amount of scale. We use about 1 node's worth of physical capacity. It doesn't actually sit on 1 physical node. It's distributed for resiliency, but capacity-wise, it's about 1 physical node worth of capacity that we consume. Last question.
So once regions are introduced, would they be managed through the same admin and tenant portals?
Yes.
Okay.
Yes.
So just one pane.
Yes. And in fact, initially at GA, Azure Resource Manager and Portal will actually run only in the first region. Even though the other regions will have each of the RPs, Compute RP, Network RP, Storage, Health, Update, but the Portal and ARM will run only on one region. And then over time, we'll also be able to distribute the Portal and ARM over the other regions. But the administration, like I said, if you go back to the UI, you will see that blade, you'll see the list of regions, click on the region, you'll be able to manage that region from that portal.
So the tenant, just like in Azure, would be able to say they want to provision
That is correct.
their
The
services.
tenant is just like Azure you provision, right? Today, if you want to provision a virtual machine in Azure, at some point in the journey of the creation of the VM, you have to select where you want to deploy it.
Yep.
Similarly, in the case of administration, when you log in, you'll get a top-line portal which says, I've got 3 regions under management. Today, I want to go and see what's the state of health. Or I'm getting alert in region 2, go to region 2, and then travel that journey that way.
Finally, on that, is there any thoughts of integrating, being able to provision within Azure itself from the Azure Stack portal?
That's an interesting question. I'm not sure we'll do it that way. We may choose to do it the other way, go from Azure, provision on Azure Stack. But we are open to it. This is something that we are still debating and discussing.
Okay.
I'll take your question, please. Packet direct for VMs? I'm not aware of this question. I'm sorry, I'm aware of the question. I don't know the answer, I'm sorry. If Spencer doesn't answer it in his talk in the afternoon at BRK 4019, please come by the booth and I'll definitely have an answer for you. Yeah. Yeah, I just don't know the answer. I don't know, so come by. If Spencer doesn't answer it, then he won't. I'm assuming you're talking about packet direct into the VM, and that is experimental, but I just don't want to commit to something which is not true. All right, folks, thank you so much for staying by. Really appreciate it, and have a good conference.